right, so we're first going to look at this business application question where we're first being asked for what is the cost at the production level of 2000. So that question is not asking anything about the derivative, it's just what is the cost. So you will simply plug in 2000 into the cost function. So again, the cost function is given here, so I will have 14,400 plus 300, and then in for my x's, I will plug in my 2000. So that will be 300 times 2000 plus 2000 squared. And that is going to give you 46,614,400,000. So that's the number that you're going to put in this blank where you're explaining just what is the cost. Now, the second part of this is what is the average cost. Now, there is a definition for average cost that we have seen before. Sometimes average cost is referred to as AC. They'll say like AC function equals, or sometimes C bar. You'll see both of those. But when you're talking about average cost, it is the cost divided by X, the quantity. So what you'll do is you'll take this 14,400 divide by X plus 300X divide by X plus X squared divide by X. Now, I always like to simplify this first. This is going to be 14,400 over X plus, and then here my X's cross out, 300, and then plus the x squared over x just gives us x. So that's our average cost. Now, specifically, they want the average cost at the production level of 2000. So you're not typing in this average cost, you're then going to plug in the 2000. So it's going to be 14,400 over 2000 plus 300 plus 2000. And doing that computation, you will get approximately 2,307.20. So again, that is the number that we'll plug in for our average cost at 2000. Now, the next part is what is the marginal cost? And we know that the marginal cost is where we start talking about the derivative. So marginal cost will be C prime. So we'll go up here and we will take the derivative of the cost function. So the 14,000 is a standalone constant, so that goes to 0. The 300x is a linear term, so we go to the coefficient, and then the x squared becomes a plus 2x. And then from there, we will simply plug in the production level of the 2000. So we plug in the production level of 2000. That gives us 3,000 or 300 plus 2 times 2,000. So that's going to give us 4,000 plus 300. So we get 4,300. Now, then it asks for what is the production level that will minimize the average cost function. So we need to be a little careful here about what we're actually trying to minimize. We're not trying to minimize cost. We're trying to minimize average cost. So to minimize average cost, remember average cost was in part B, where we found that the average cost function was this 14,400x plus 300 plus x. So that's the function that we're trying to minimize. Now, to minimize that function, we need to apply our first derivative or second derivative test. So the first derivative test is the one that always works. So a lot of times students will go to the first derivative test, but remember with the first derivative test, the first thing we need to do is find our critical number. And to find the critical number, we need to get our derivative. So we're first going to take our derivative and set it equal to 0 or does not exist. So what that's going to give us is we need to simplify this first fraction, and what I'm going to do is write it over here so it's not so scrunched up. But what I'm going to do is I'm going to say I'm applying the first derivative test. My average cost function is 14,400 x to the -1. Now the reason why I'm doing this -1 is because I want to take the derivative, and then plus 300 and then plus x. So I'm going to differentiate that function. So bring down the negative 1, get negative 14,400 x to the negative 2. The plus 300 is a standalone constant, goes to 0, and then the x to the first is a linear term, so it becomes a plus 1. Now remember that we want to find critical numbers, and to find critical numbers we want one fraction. So because we want one fraction, we are going to move the negative exponent as soon as we possibly can. So this is going to look like negative 14,400 over x squared plus 1, and that's what we're going to be looking at to get the one fraction. Now, to get our one fraction here, the first thing is to move the negative exponent. The second part of this is usually going to involve getting an LCD. So our LCD here between x squared and 1 is just going to be x squared. So the second term will need to get multiplied by x squared over x squared. Now that we have that LCD, we can write this as x squared in the denominator, and then the negative 14,400 plus x squared in the numerator. So that is my first derivative. Now, once I have that first derivative, I can then set the numerator equal to 0 to find the critical number, and I can set the denominator equal to 0 to find any critical numbers that come from the denominator. So setting the numerator equal to 0, I get negative 14,400 plus x squared equals 0, and denominator equal to 0, I get x squared equal to 0. Now for this first equation, remember we're trying to undo PIMDES, so we will add 14,400 to both sides and get x squared equals 14,400, and then take the square root of both sides. So that gives us x equals plus or minus 120. Meanwhile, for our denominator equal to 0, we're going to take the square root of both sides, and that gives us x is equal to 0. All right, now this is how it would, like if you just were not thinking about anything else in the world and you were going mechanically through this process, you would say there are three critical numbers. You would say there's plus or minus 120 and 0. However, remember that x represents a quantity. It represents the production level that we are at. Now again, they don't tell you what you're producing, but they do tell you that x is the quantity that you're producing. So when you're looking at this and you get these critical numbers of plus 120, negative 120, and 0, immediately you know that negative 120 is not going to work for you, right? Because the negative 120, it means you're producing negative units. So technically 0 is not a critical number, and this is the long-winded explanation for it. It's not a critical number because of the domain. If you look back at the average cost function, you'll notice that x was in the denominator. And so for that reason, the assumption when you write the average cost function is that x is not equal to 0. However, if you don't notice that and you just draw your number line with the 0 and the 120, I want to just show you really quickly that it will come out very quickly how 0 is not going to work for us as an answer to minimize our average cost. Because what would happen is I would draw my derivative number line and I would plug into the derivative. So I would plug into this negative 14,400 plus x squared over x squared. And when I do that, when I plug in my, let's say, negative 1 into this, I would get negative 14,400 plus negative 1 squared over negative 1 squared. And that would give us a negative in the numerator and then a positive in the denominator. So that negative would tell us that we are decreasing. Meanwhile, we would have from 0 to 120, we would end up with 1 squared over 1 squared. That would also give us a negative over a positive. So that would tell us that we are continuing to decrease. And then I would plug in for my 120, maybe I plug in 122. That gives us negative 14,400 plus 122 squared over this 122 squared. And that would give us a positive, because this 122 squared would be bigger than the negative 14,400 over a positive. And so that positive would indicate that we're then increasing. So from our number line here, we're decreasing, decreasing, and then increasing. And we see that the 120 is the only critical number that will minimize the average cost. So our final answer, long-winded explanation there, we took our derivative, and again, this is necessary, like we need to do this work. We took our derivative, we found our critical numbers. This 120 was the only critical number that produced the minimum, minimizing the average cost. So what we would say is we would say the production level that will minimize the average cost is 120. Now, when we are asked for the minimum average cost, then that's when we're going to go back to the average cost function, the 14,400 over x plus 300 plus x, and plug in our 120. And that will give us 540. And that is our actual in dollars, $540 as the minimum average cost. And they don't want you to put the dollar sign, so it will just be the 540.